Welcome to Tomorrow Unveiled. For years, space felt like something from the movies, didn't it? A distant dream.
Definitely. Far off.
But this past week, it honestly feels like that future is just unfolding right in front of us
Yeah.
at an incredible speed. We're seeing things happen that are really changing the game beyond Earth.
It's quite something.
And that's exactly what we want to unpack for you today. We're exploring Beyond Earth this week in space. Here at Tomorrow Unveiled, our whole mission is really to cut through all the noise. Our dedicated research team dives into all the latest, most critical info, and they pull out those essential nuggets you really need.
Yeah, distilling it down.
Exactly.
Yeah.
And let me tell you, the week of June 20th to 27th, 2025, wow. It's been genuinely a watershed moment for space tech. The sheer amount of news can make your head spin, honestly. But we've zeroed in on the most impactful insights for you.
And what's really fascinating, looking at the analysis from the team, is how all these different things, a rocket test here, an orbital factory there, new rules coming in, they aren't just separate news items.
Right.
They're actually fitting together, like pieces of this huge puzzle. They're weaving this bigger story about humanity really starting to build a permanent presence beyond Earth. It's less like lots of individual sprints, more like, building a whole new continent up there, brick by foundational brick. It's a fundamental shift, really.
That's a fantastic way to think about it, a new continent in the sky. Okay, so let's talk about those foundational bricks, starting with the most basic need, getting there. And maybe even more importantly, getting back safely and affordably.
The access problem, always key.
Exactly. So we're diving into the global race for reusability and propulsion breakthroughs. And this area is just incredibly dynamic, super competitive. Our research team found, some really inspiring successes, but also some pretty major setbacks this week.
It's never straightforward, is it?
No, it really reminds you how tough spaceflight still is. So on the success side, let's look at China's commercial player, Landspace. They made a really significant move with their Zhuge 3 rocket.
Yes, the static fire test.
Right, a successful 45-second static fire of the first stage. All 9 of its methalox engines firing together. Now, for anyone listening, methalox just means methane and liquid oxygen fuel. This isn't just any test, though, is it? It feels like a major step for a big reusable rocket.
Oh, absolutely. Landspace already made waves with Zhuge 2. Remember, the first Mechalox rocket to actually reach orbit?
Right, that was huge.
So this, with Zhuge 3, is them scaling that tech up significantly. They're talking about an orbital launch maybe even later this year, third quarter, and the Methalox fuel choice. That's really key.
Why is methalox so important here?
Well, our research indicates it's becoming the preferred fuel globally for these next-gen reusable rockets. It seems to hit that sweet spot, power, cost, reusability, even being a bit cleaner. It's accelerating the whole field, and it shows this isn't just a U.S. game anymore. It's a truly multipolar, heavy lift market emerging.
So it's validation, but also, like you said, a direct challenge to the established players. SpaceX, Blue Origin.
Definitely both. Keeps everyone on their toes.
Okay, that's fascinating. The competition is definitely fierce. But what really jumped out at me from the research, and honestly it kind of surprised me, was a completely different player showing up.
Oh, where's this?
Japan's Honda. Yes, Honda, the car and motorcycle company.
Honda. Okay, now that is interesting.
Right. They apparently made a really successful launch and, crucially, a precision landing test of their own reusable rocket prototype. It only went up about 270 meters, but get this. It landed just 37 centimeters off target.
Wow, 37 centimeters.
Yeah.
That's remarkable precision for a landing test.
Isn't it? So how does a company like Honda, known for engines and manufacturing cars, suddenly pivot and potentially disrupt the space launch market? Are they just leveraging their existing know-how?
That's likely a huge part of it. Think about their expertise in mass production, complex combustion engines, very sophisticated control systems. These are directly applicable.
Okay.
Honda's basically showing that the core tech for vertical takeoff and landing, things like precision guidance, engines you can throttle up and down smoothly, it's becoming more accessible. It means companies outside the traditional aerospace bubble, these big industrial players, can actually become serious contenders.
So it could really shake things up. More competition, maybe different kinds of innovation.
Exactly. It could really diversify things. You get this cross-pollination between industries, which often leads to breakthroughs. Very exciting to watch.
It definitely is. Okay, but let's balance the ledger. It wasn't all successful tests and surprising new entries. Space is hard, as we always say.
Always. The physics doesn't care about your business plan.
True. So the past week reminded us of that reality too. Northrop Grumman, for instance. They did a full-scale static fire test of their BOLE booster. That's for NASA's big SLS rocket, the Artemis program.
Right, the booster obsolescence and life extension motor. Big deal for SLS Block 2.
Huge power, over 4 million pounds of thrust. I mean, you just imagine that. But
Yeah.
the test ended pretty dramatically. A catastrophic nozzle failure.
Yeah, saw the reports. That's not good. But also kind of the point of ground testing, isn't it?
Well, yeah, better on the ground than in flight, obviously. But what does a failure like that mean for a program like Artemis? That booster is meant for future deep space stuff, right?
It is. The BOLE booster is essential for the SLS Block 2 version, which needs to lift heavier payloads for later Artemis missions, like Artemis and X, planned for the 2030s. So, a major failure now. It definitely introduces uncertainty, potential delays.
Which Artemis really doesn't need, given the budget pressures and timelines.
Precisely. It's a critical learning moment, yes, a test-as-you-fly philosophy applied on the ground. But it has real-world schedule consequences. It just highlights the massive engineering challenges, even for the big, established players.
And it wasn't just Northrop Grumman. SpaceX had an issue too, didn't they, with Starship?
Yeah, Ship 36, it was getting ready for what would have been its 10th test flight, experienced an explosive anomaly during propellant loading, just sitting there on the test stand.
Ouch. Before it even got off the ground, do they know what happened?
Early signs point to a COPV failure. That's a composite overwrapped pressure vessel, basically a high-pressure tank.
Okay. This kind of incident, especially with Starship being so enormous and complex, it really makes you think about SpaceX's whole fail fast, learn fast approach, doesn't it?
It absolutely does.
I mean, is there a point where failing fast with something that big just becomes too expensive or maybe even slows things down because you have to rebuild so much?
That's the multi-billion-dollar question, isn't it? It really suggests that scaling that fail-fast model might have diminishing returns. It works brilliantly for smaller things, iterate quickly, but when you lose an entire Starship vehicle before you even light the engines, that's a different scale of setback compared to, say, an anomaly during flight where you still get tons of data. This means months of rebuilds, huge costs, just to get back to the same test step. So when you put these things side by side, Landspace and Honda pushing forward, Northrop Grumman and SpaceX hitting these major dramatic roadblocks, what does it tell us?
Yeah, what's the takeaway?
Well, it shows there are fundamentally different philosophies at play globally for achieving reliable, cost-effective space access. Everyone's trying to crack the same nut, but they're using very different hammers. Each way has its own risks, its own potential rewards. The industry's still figuring out which path or paths really lead to sustainable success in the long run.
That's a really insightful way to frame it. Different philosophies, different risks. Okay, so it's clear that just getting to space is still this massive challenge with lots of different bets being placed.
Absolutely.
But let's shift gears. Beyond just the rockets, what about actually doing things up there? Building that continent in the sky you mentioned, because this week also saw some incredible progress in making a real orbital economy happen.
Yes, the in-space operations side, very exciting developments there.
So let's look at building the future in orbit, in space manufacturing, servicing, and intelligence. This is where things get really interesting, seeing industrial capabilities actually move off-planet, concepts becoming real. And first up, in space manufacturing. It's not just talk anymore. The European Space Agency, ESA, hit a major milestone with their orbital metal forge.
The 3D printing in metal, that's huge.
Isn't it? They successfully 3D printed the first metal part stainless steel up on the ISS. And crucially, they got it back down to Earth safely for analysis.
Which is key. You need to verify the quality.
Exactly, but think about the implications. This is potentially revolutionary for just-in-time logistics on long missions. Imagine heading to Mars. You might not need to pack every single spare widget you could possibly conceive of needing.
Precisely. The ability to print robust metal parts on demand. It fundamentally changes the whole equation for long-duration spaceflight, especially deep space.
It's like what's putting the hardware store in orbit.
That's a perfect analogy. Right now, our hardware store is always Earth, months or years away for a Mars crew. If you can put that capability locally, in orbit, or even on the Moon or Mars eventually.
It makes missions much more resilient, right? More self-sufficient.
Totally. And it cuts down massively on the sheer weight you have to launch from Earth, which is always one of the biggest constraints and costs. It's about making space exploration actually sustainable.
Okay. And staying with manufacturing, but moving over to the UK, Spaceforge launched Forge Star 1. Our research team notes this is the UK's first satellite dedicated specifically to in-space manufacturing.
Right, focusing on those high-value materials.
Exactly. Their mission is to make crystal seeds for next-gen semiconductors. Apparently, microgravity helps make them way better. Plus, they're testing re-entry tech to bring stuff back. This feels like a really smart economic play.
It is. It targets a niche where the unique environment of space offers a distinct advantage.
So what's special about making these crystal seeds in space? Why bother?
It boils down to basic material science. On Earth, gravity causes convection currents and sedimentation when crystals grow. Tiny imperfections. In microgravity, those effects basically vanish.
So you get purer, more perfect crystals.
Much more perfect. And for semiconductors, even minuscule flaws can kill performance or yields. So making these initial seeds in space could lead to much better materials back on Earth, things like more efficient solar cells, faster computer chips, maybe even better medical crystals.
So the idea is the material they make is so valuable it justifies the launch cost.
That's the economic model, yes. Focus on high-value, low-mass products that you simply can't make as well, or maybe at all, on Earth. It's a clever strategy showing a path towards a potentially very lucrative slice of the space economy. It's not just about, can we make stuff? It's, what should we make in space?
Find that unique selling proposition of microgravity. Makes sense.
Hmm.
Okay, moving beyond baking things, what about fixing things or moving them around? Orbital servicing.
Also a critical piece of the puzzle.
Our research team flagged that Starfish Space is gearing up for the first ever commercial satellite docking demo. They're using their Otter Pup-2 satellite. This seems like a big step for extending satellite life or, cleaning up space junk.
It's fundamental. A successful commercial docking demo is a massive proof of concept. Starfish is trying to show they can do complex docking maneuvers with relatively small, agile satellites using advanced software rather than relying on big, expensive robotic arms.
So a more affordable, scalable approach.
Potentially, yes. If they nail this, it opens the door to refueling or repairing expensive satellites that are running low on fuel but otherwise perfectly functional. That saves operators huge amounts of money. And as you said, it's a vital technology for eventually tackling the space debris problem actively. We're getting closer to needing orbital tow truck space.
Little tow trucks, I like that.
Right.
Okay, and shifting focus again, but staying in orbit, looking back at Earth, our perspective is literally changing.
New eyes in the sky.
Yeah, ESA's Biomass satellite just sent back its first images. And this thing is pretty special. It has the world's first space-based P-band synthetic aperture radar.
Key-band SAR, that's the key.
Our research described it as giving us X-ray vision for forests, like a CT scan for entire ecosystems, allowing true 3D mapping of carbon storage. How big a deal is this really for climate science?
It's potentially revolutionary, honestly. For decades, we've mostly seen forests in 2D from space, the tops of the trees. Biomass, with that long wavelength P-band radar, penetrates the canopy and sees the actual structure, the trunks, the branches. It gives us a volumetric measurement.
So we can finally know how much carbon is really locked up in forests.
Exactly. That's been one of the single biggest uncertainties in our global climate models. How much carbon is in the forests and how is it changing? Biomass promises to slash that uncertainty. It'll provide really solid, transparent data.
Which could be huge for things like international climate agreements, right? Holding countries accountable.
Absolutely. And for designing better conservation and reforestation efforts. It's giving us the ground truth, or maybe the forest truth that we've desperately needed.
Incredible. And there's another leap in observation tech, too, from Muon Space's FireSat. They shared their first images this week as well.
Ah, yes. The Wildfire detection constellation?
Right. It's a prototype constellation, but it's using advanced infrared sensors and, critically, an AI pipeline to spot even small fires almost instantly.
That combination is powerful.
It seems like a perfect blend. Specialized sensors, lots of satellites for quick revisits, and AI to actually make sense of the flood of data. Can you talk a bit more about why the AI is so crucial there?
Well, think about it. A constellation like FireSat, maybe 50 satellites eventually, covering the globe every 20 minutes or so, it's going to generate an absolutely immense amount of infrared data. Far too much for humans to sift through in near real time looking for tiny hotspots.
Right, you'd miss things.
Or be too slow. The AI does the heavy lifting. It's trained to spot the thermal signature of a fire, distinguish it from other heat sources like engines or even just hot rocks, calculate the location, and send an alert to firefighters within minutes of detection.
Minutes. Wow. That could make a huge difference in stopping fires before they explode.
That's the goal. This fusion, specialized hardware, dedicated constellations, AI analysis, It's a model we're going to see applied to many other global challenges. Disaster response, agriculture, maritime monitoring, you name it.
So, tying this all together, manufacturing, servicing, these amazing new observation tools, these aren't just cool experiments anymore.
No, they're becoming the essential building blocks for a truly sustainable, maybe even self-sufficient human presence in space. And at the same time, giving us incredibly powerful new tools to manage our own planet better.
It really feels like we're building the infrastructure for the future, both up there and down here.
Ah.
Okay, a quick reminder for everyone listening. If you're finding this insightful, please do take a second to like this video, subscribe to Tomorrow Unveiled, and definitely hit that notification bell so you don't miss our future updates.
It really helps get the word out.
It does. And if you're listening on a service like Apple Podcasts or Spotify, we'd be so grateful if you could leave us a rating and review for Tomorrow Unveiled. It genuinely helps new listeners discover the analysis we do here.
We appreciate the support.
Absolutely. And we love hearing from you. Whether you're on YouTube or your podcast app, drop a comment. Let us know what you think about these space breakthroughs we're discussing and what you see coming next for humanity beyond Earth. Okay, so we've talked about the tech, the rockets, the orbital factories, the amazing sensors. But as space gets busier, more commercial, and frankly, more valuable, it also gets more complicated, doesn't it?
Inevitably. More actors, more stakes, more rules needed.
Exactly. Which brings us to our next section, the evolving landscape, regulation, geopolitics, and future foundations. This might seem less flashy than rockets, but it's absolutely vital for where things are heading.
The framework that everything else operates within.
Precisely. And a huge development here, highlighted by our research team, is the proposed EU Space Act. The European Commission is putting forward this really comprehensive, unified set of rules for space activities.
A landmark proposal, really, trying to get ahead of the curve.
It seems like it. It's built on three main pillars, right? Safety things like handling space debris, avoiding collisions, resilience like cybersecurity for satellites, and sustainability looking at environmental impacts, promoting things like in-orbit servicing.
Covers the key areas, yeah. Safety, security, sustainability.
But what makes this potentially really impactful beyond just Europe?
Well, the fascinating part is its intended reach. The proposal says these rules wouldn't just apply to EU companies, they'd apply to any operator from anywhere in the world if they want to offer space-based services within the European market.
Ah, okay. So if you want to sell satellite data in Europe, you play by Europe's rules.
That's the idea. It's leveraging something called the Brussels effect. Because the EU is such a huge market, its regulations often become de facto global standards. Companies just find it easier to comply worldwide than to have different standards everywhere.
So Europe is trying to export its vision for safe and sustainable space.
Essentially, yes. It's a strategic move to shape the global norms, ensure safety, but also, let's be honest, promote Europe's own space industry within that framework. It clearly signals we're moving away from a Wild West space environment towards something more regulated.
That's a really significant shift. And speaking of shaping the landscape in different ways, our research team also picked up on increasing geopolitical maneuvering. For instance, reports about Blue Origin's leadership spending time lobbying in Washington, D.C.
Trying to secure more government contracts.
It's not exactly surprising given the money involved, but what does that tell us? Is space becoming just another arena for political influence and lobbying?
It certainly raises that question, doesn't it? As these massive government contracts, think NASA's lunar landers or Pentagon launch contracts, become absolutely vital revenue streams for companies like Blue Origin or SpaceX, they're naturally going to use all the tools available. That includes traditional political lobbying.
So the competition isn't just technical anymore.
No, it's also political. It happens in the engineering labs, on the launch pad, and in the halls of Congress. It just shows how deeply intertwined space is becoming with regular terrestrial politics and economics. It's a sign the industry is maturing, perhaps, but it adds another layer of complexity.
And sometimes, space activities have very direct terrestrial consequences. Our team flagged the incident with SpaceX Starship debris landing in Mexico.
Yes, after one of the earlier test flights.
Right. And now Mexican authorities are conducting a formal investigation, potentially even preparing a lawsuit, citing security and environmental impacts. That really brings it home, doesn't it?
Right.
What goes up or tries to go up can affect people and places on the ground.
Absolutely. It underscores that space isn't happening in a vacuum anymore, literally or figuratively. These activities have real-world impacts, cross borders, and increasingly fall under national jurisdictions and environmental regulations.
So taking all this together, the EU Space Act, the lobbying, the debris incident, what's the bigger picture?
I think it clearly signals that the Wild West days of space, if they ever truly existed, are definitively over. Space development isn't just for engineers in clean rooms anymore, operating outside
The
politics.
stakes are too high now.
Way too high. Companies, nations. They all have to navigate this really tricky balance now. How do you keep innovating rapidly, pushing the boundaries while also meeting increasingly strict rules, managing political relationships, and dealing with the very real consequences of your actions? It's a new kind of frontier one with a lot more rules, regulations, and stakeholders involved.
What an absolutely packed week we've just walked through here on Tomorrow Unveiled. It's kind of breathtaking, actually. We've seen just immense progress, but also stark reminders of the risks and the sheer difficulty of pushing beyond Earth.
It's never dull, that's for sure.
No kidding. But it really feels like this future we keep talking about isn't just coming soon. It's being built piece by piece right now.
I agree. And the key themes from this week's analysis are pretty clear, I think. First, that global race in reusable launch is undeniable. It's multipolar, it's accelerating, and it's marked by both these incredible successes and significant, costly setbacks. Each one teaches us something, though.
Definitely. And second, that shift from concept to reality for in-space manufacturing and servicing, it's happening. We're genuinely laying the groundwork for real orbital economies, making ourselves less reliant on Earth for every little thing.
Then there are the new ways we're seeing our own planet. Those new observation capabilities, the 3D forest mapping with biomass, the AI-powered fire detection with FireSat, they are profoundly changing how we can monitor and hopefully manage Earth's critical systems. Space is becoming an essential tool for planetary stewardship.
And finally, it's unavoidable now. Regulation and geopolitics are completely intertwined with space operations. It's not just about the tech anymore. It demands really sophisticated thinking from everyone involved, companies, governments, international bodies.
Which leads to a final thought, perhaps, something for you to ponder. As we rely more and more on space for everything, climate data, global communications, navigation, maybe even resources someday, how will we manage that delicate balance? The balance between the relentless drive for faster innovation and the growing need for careful, stringent regulation to ensure safety, sustainability, and security for everyone. How that balance gets struck, well, that will shape our collective future among the stars.
A really crucial question to think about, and one we'll definitely keep exploring right here on Tomorrow Unveiled. Thank you so much for joining us today. We'll be back soon to unveil more of what's next.